In this video, we will solve another mathematics Olympiad problem, and the problem is that 1 divided by square root of x plus 1 divided by square root of y is equal to 1 divided by square root of 20, where x and y belong to the set of natural numbers, that is positive integers. So we have to find all the values of x and y which satisfies this equation. So please pause the video and work out on it, and then resume when you are ready. Now let's see the solution. So we have this 1 over square root of x plus 1 over square root of y equal to 1 over square root of 20. So we can rewrite it as, let's bring this to the right side. So 20 is 4 multiplied by 5. So we can write it as square root of 4, square root of 5 multiplication. So square root of 4 is 2. Root 5y. This is 1 over square root of x. So let's take the reciprocal on both sides, that is divide by itself 1. So this denominator becomes numerator and numerator becomes denominator. So square root of x equal to 2 root 5y divided by root y minus root 20. So this 5y now we can square on both sides so that this becomes x. So this is x, and then on the right side we have 20y divided by, this is a minus b whole square, that is a square plus b square minus 2ab, that is 2a is root y and then b is root 20, which is 20y divided by y plus 20, then minus, again 20 can be written as 5 multiplied by 4. So 2 will come out, so 4 root 5y. Now this x belongs to natural number. So the right hand side should also be natural number. X and y both are natural numbers. So this is natural number, these two are natural numbers. So this part should be a natural number in order for the whole term to be natural number. So 4 is already natural number, so root 5y should be a perfect square. So let's see. So we have root 5y should be a perfect square. So one number, so this number should be a perfect square. So one of them is 5 and 5 is not a perfect square. So there should be some number which multiplies this. So at least one of the numbers should be some multiple of 5. Otherwise, let's say we have 3, then this will not be a perfect square again. So at least one of the numbers should be 5 if we break this y further. And now this 5 multiplied by 5 is a perfect square, and we can have either one or some other perfect square, that is 5y should be of the form of 5 times a square. So this 5 is already there and this y is some number, let's write it a square. It can further be b square, so that whatever number is there, it should be a perfect square, and there should be one additional 5 because we already have 1 5. So 5y is of the form of 5a square. Similarly, if you write, so here we had moved y to the right hand side. If we move x to the left right hand side, the same logic will be there. Y will be 20x, because these are exactly similar. 20x divided by x plus 20 minus 4 root 5x. So by that logic, 5x should be of the form of 5b square, and again a and b should belong to natural numbers just like x and y. Now let's rewrite our equation, that is 1 over root x plus 1 over square root of y equal to 1 over square root of 20. So this should be x and y should be this 5a square, because if we multiply by 5 we will get 5 square a square, which is a perfect square. So 1 over root 5a square plus 1 over root 5b square equal to 1 over 20 can be written as 2 root 5. Now this a will come outside, so we will have 1 over a root 5 plus 1 over b root 5 plus 1 over is equal to 1 over 2 root 5. So root 5 gets cancelled and we have 1 over a plus 1 over b equal to 1 over 2. Let's take the LCM. So a plus b equal to 1 over 2. So let's do the cross multiplication. 2a plus 2b equal to ab. Let's bring it to the left side. So 2a minus ab plus 2b equal to 0. So we have 2a minus ab plus 2b equal to 0. So within these first two terms we have a as common. So a multiplied by 2 minus b. Similarly here we can take b as common and then 2 minus b, or let's try to get some common term. So we will factorize it. So 2 minus b, so we can have 2 common and then we will have b 2b and then minus 2. If we do, we have minus 4, so we will add 4. So this is exactly reverse of this. So let's take minus 2 here, then it will be minus b plus 2 and then we have 2b. So if you break this term we get 2b minus 4, but here we had just 2b, so we added plus 4. So now we have a minus 2 multiplied by 2 minus b equal to minus 4, or let's make it plus 4 and reverse these two values, sign plus b minus 2, so b minus 2. So a minus 2 multiplied by b minus 2 equal to 4, and remember that a and b belong to natural numbers. So a minus 2 is some integer, b minus 2 is also some integer, and this can be broken as 2 multiplied by 2 gives 4, 1 multiplied by 4 gives 4, 4 multiplied by 1 gives 4. So if this is the case that a minus 2 is 2, then let's take a b. So for the first case a will be, if a minus 2 is 2, then a is 4 and b is also 4, and if a minus 2 is 1, then a is 3, b minus 2 is 4, so b is 6, and here the reverse 6 3, but these are a and b, we want x and y. So remember that x is 5b square, y is 5a square. So let's take a square of these. So a square b square for these cases will be 16, 16, 9, 36, 36, 9, and then we have to multiply 5 to get x and y, or y and x. It does not make any difference. So multiply by 5. So we get x and y as 80 and 80. It's one possibility. Second is 45, and 36 multiplied by 5 is 180, and here it's 180 and 45. So these are the possible values of x and y which satisfies this equation. So I hope you liked this problem. It's slightly on the tougher side, so if you don't get it, please revisit the video, and if you want more such mathematical problems, please subscribe the channel, and thanks for watching.